Hi, this is Rob. I'm here to give you a really high-level overview of where this is going and what you can expect in the weeks ahead. Most of us come to this training as accomplished developers, and that means that we've accumulated a body of knowledge about how computers work and how software works. We know how to approach certain problems. We know the pros and cons of doing things certain ways. In general, we call that experience. Ethereum is unlike any software platform that preceded it. And that means that there's going to be a period of disorientation. You're going to find that past experience and accumulated knowledge may actually work against you in this new environment where new rules apply. These lessons will unfold a path for you so that you can find your way through this forest. The instructors are here to help you with your assignments and steer you back to the path. At the end of this path, where this training will guide you, is a place where you can feel confident that you understand Ethereum and smart contract technology and can work with it confidently. I'd like to begin by explaining what a smart contract is. This is my explain it like I'm 5 for smart contracts. And these are ideas that I wish had been laid out for me clearly and unambiguously at the beginning of my learning experience. A smart contract is not a replacement for a server. True, smart contracts have data storage, and true, smart contracts have logic, but smart contracts are not a one-to-one replacement for something like a SQL server or something like a web server. And this is part of the disorientation that I alluded to. If a smart contract is not a replacement for a server, then what exactly is it? A smart contract is the eternal part. It has to be perfectly simple and perfectly complete. It's the part that provides evidence of the trustworthiness of the system. It explains what the system does, and it provides proof that the system does it correctly. And as we're going to see in the lessons that follow, these are things that cannot be done in a traditional database or in a traditional server environment or even in a traditional cloud environment. Blockchain solves for application requirements that cannot be solved any other way. The smart contract is the part that ensures the application correctness for eternity. It's focused on application integrity and the integrity of the data. The smart contract is the authoritative truth. It's the source of truth in the same way that, when the pump disagrees with the cash register at your local gas bar, there's a little sticker on the pump that says that the pump wins. With a smart contract, the contract data always wins, even if the servers and the clients disagree. Smart contracts are completely transparent, and the data contained within smart contracts is completely transparent. And this is going to take some adjustment on our part. We have to learn to operate in an environment where everyone can see all the data at all times. We have this idea of establishing trust. And the trust comes in large part from the idea that the smart contract is there for all to see, and it can never be changed. Now, when I first internalized this idea, I started developing concern. The idea that the first version of the software released into production would have to stand for all time was a concern. And the idea that the smart contract would be entrusted with significant value led to something I might describe as concern squared. This is powerful stuff. We need to approach it with respect. To help you learn how to handle this technology safely, we have some general ideas. We incline to minimalism. The simpler the contract is, the better. All reductions in complexity are desirable. We want to limit the scope of the smart contract to just the bare minimum essential functions and the essential state and essential state changes. We keep the contract focused on application integrity, and wherever possible, we externalize unwanted complexity. So this may sound a little strange coming from a smart contract training program such as this, but a good rule of thumb to keep in mind is that if an action can possibly be done outside of the smart contract, then you should do it outside of the smart contract. Smart contracts ask us to take pride in the simplicity of our creation rather than the complexity of it. My favorite quote on this topic comes from a guy named Tony Hoare, who was a winner of the 1980 Turing Award, and he's best known for his invention of something called the quicksort algorithm, which is still important today. And Tony says there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated that there are no obvious deficiencies. And the first method is far more difficult. In the world of smart contracts, we're aiming for obviously no deficiencies. And I put this here to remind us that simplicity is our goal. Okay, so what kind of habits can we form to create that kind of quality? Now, when I use the word discipline, I don't mean it in the sense that somebody's going to be punished. I mean it in the sense that someone follows a daily routine, develops a set of habits, like a kung fu master does everything a certain way all the time, and through repetition develops habits that ultimately lead to good results. So in this discipline, we're going to minimize the surface area. This is part of minimalism. It just means that the functions that we expose and the scope of the contract is going to be as small as possible. We're going to stress readability. It's much more important that the contract is clear and understandable than, for example, premature optimization. When I say test and test again, I mean that it's really important that you do your quality assurance before the system goes into production. In the beginning, in the development stage, it can be very informal and things can change all the time, but we have to remember that when these contracts are released into production, they're immutable, they're unchangeable. Non-trivial problems may be difficult or impossible to fix. Generally speaking, an independent audit is advisable before a contract is released into production. And a popular approach to pre-production testing is to offer a bug bounty and put the contract on testnet for rehearsal and invite honest players to report defects that they find rather than waiting for the contract to go into production where the dishonest players might exploit a problem with the code. We can get a little more practical here by introducing some best practices for Solidity smart contracts. The first one is fail hard and fail early. Now this is just about the opposite of the way most software works. In my experience, there's usually almost an obsession with handling errors gracefully. And usually there's a user out there or a system administrator out there who wants to fix the problem. And because we're nice people and because we're courteous, we want to report something about the error. We want to provide informative information about what went wrong. And above all, we want to make sure that the software itself never crashes. In smart contracts, we're going to do the opposite of that. We're going to seek out and seize every opportunity to crash. If something is not right about the transaction, if the transaction doesn't pass validation, if there's a user input error, we're going to crash hard. We're going to do it at the first opportunity. And we're going to be stubborn and rude about it. The contract's focus is to enforce integrity. And remember, we also want to minimize complexity. So explaining the nature of the problem to the user always introduces unwanted complexity into the contract. And so simplicity trumps user-friendly. We're not going to explain anything about what went wrong. We're going to write our code as if we're certain that there's going to be a code review. We're going to stress readability just to be courteous to the people who are going to review the code for us. Remember, the code review is going to happen on multiple levels. There will be an internal code review as your team determines that the software is ready to go into production. There may be a code review publicly as the contract is deployed on a test net, perhaps in conjunction with that bug bounty. And then when the software is released into production, there will be a code review as you establish trust in the system. Inherently, the trust in the system comes from being able to see the contract and self-assess what the contract does. So this has some implications in terms of protecting intellectual property. It's very transparent. It's quite different from a world in which the software is a black box. This software is generally out there for the whole world to review. There are some cases in the compiler where there are some default settings that you can get when you're silent about a particular issue. In most cases, we suggest that you be explicit about your choice. That helps code reviewers avoid oversight. You can see exactly what your intention was, and you should make your intention clear every step of the way. You're aiming for a piece of software that is obviously correct. Names matter. This also helps code reviewers understand what the program does. So there are emerging standards for the correct naming conventions for functions and variables, things like that. And we strongly suggest that you observe those standards so that people can look at your code, recognize the patterns, recognize the naming conventions, and understand what's going on. So just some quick introduction. Names are important. We use camel case for variables and functions, title case for contracts and constructors, and something called structs, which are very similar to constructors. And functions should describe actions, that is, what they do. So if a function is called status, it doesn't really describe what is going to happen. A better idea is to call the function setStatus or getStatus so that there's some directionality in the name and so that people understand what to expect when they call the function. I often find myself describing smart contracts and the way that we go about designing them as being the opposite of traditional software. We're all familiar with the idea that we have a database and we have an application, and the data generally lives outside of the application. If the data is inside the application, we call that a hard-coded value. It's part of the binary executable. And there are lots of reasons to not want to do that. The obvious one is that if a value is coded inside the program, then it's not really very easy to change that value except by recompiling the program. So we all know that it's a great idea to store data external to the programs. Ethereum comes along and asks us to invert our thinking about this subject. In Ethereum, a contract's storage space is inside the smart contract. That means there's no way to go around the application and talk to a database directly. There's no way to go around the contract and amend the data. You have to go through the contract functions as they were designed. And we don't get to add it later. We don't get to amend it later. In my opinion, a good rule of thumb is to consider not just the functions that are needed immediately today for today's inception of the application, but to think of every possible access use case for that data ever. And I'm in the habit of implementing create, retrieve, update, and delete functions for all data stored inside the contracts, even if they don't seem to be immediately needed today. The idea here is to cover all bases and think about what might ever be needed in the future. But delete is a special case. As we know, data in Ethereum is eternal, and so nothing really gets deleted. Still, application use cases usually have a need for some kind of a logical delete. So you have to think about what that means in the context of your application. Ethereum has something called the event log, and then event emitters that emit events as important things happen in the contract. Now, there's no clear guidance on how to use event logs. It's just a tool, and as smart contract developers, we can use it any way that we like. In my opinion, the best way to use the event log is to create something similar to a database transaction history. That means it should be theoretically possible to reconstruct the entire state history of the contract by replaying the events in order. That means that every time there's an important state change in the contract, we should emit a corresponding event. Here's a little detail that bears mentioning right at the beginning. In Solidity contracts, you'll see these pragma statements that refer to a version of the compiler that should be used. And sometimes you'll see the little hat symbol in front of the version. And what that means is that any version as good as or better than the version described will do. That's not meant to imply that the compiler isn't important. Before a contract goes into production, the compiler is exceptionally important. As you're doing unit testing and running your bug bounties and doing your contract audits and all of that good stuff before it goes into production, it's vital that you're using the same version of the compiler every time. Just remember that the compiler itself is a potential source of defects. So if you release code that came out of a different version of the compiler and it's materially different from the version of the contract that was tested, well, that just won't do. It's fine for development, it's no good for production. Okay, so I've explained a few do's and don'ts and general rules about working with smart contracts. I want to step back a little bit here and just describe the big picture. The contracts themselves can hold state variables, they can hold funds, they can release funds, they control the evolution of the state, that is the data stored inside the contract, and contracts are deterministic actors. They're virtually indistinguishable from users, and we generally write our contract as though the user might be human or might be another smart contract. As a reminder, contracts are the source of authoritative truth. They prove that the application is trustworthy and will work in a predictable way. Now, earlier I mentioned that smart contracts fail hard and fail early, and they are stubborn and they are rude and they don't explain anything about what's going on. And that might make your spidey sense tingle a little bit because it sounds like we're going to make really user-hostile applications. That's not really the whole picture. By the time an error bubbles up to the level where the user can see it, of course we want it to be user-friendly. We're simply externalizing that concern from the smart contract itself. So we're fully leveraging smart clients, and they might be a browser app or iOS or Android app. They can even be a server. To demonstrate how this works, we'll be using jQuery and AngularJS, and we'll be exploring other front-end frameworks and interfaces such as Node.js. So all kinds of things are out there, and in the context of Ethereum, we call all of those things clients. Now it's challenging to get started with Ethereum. When I was doing self-study, I found it very frustrating. There, I just found myself like this guy thinking, my goodness, there's got to be a better way. The challenges can be summed up as you have to choose a set of tools and get them set up. You have to have a blockchain running. You have to have funding in your accounts, and you need a bunch of test accounts to try things out. You're going to be dealing with some tedious syntax depending on which level of the stack you're trying to work at, and you get very delayed feedback. Mining itself means that the system is not especially responsive, and that itself slows everything down. A big part of the beginning of this course is to give you a grand tour of the tools, to familiarize you with the tools, and to help you get a sense of your workflow and the appropriate tool to use for any given situation. You'll see quite a few tools as we move along. To give you an idea of where this is heading, we're going to explore something called Remix, formerly known as browser Solidity. That's an online compiler and contract testing tool. We're going to use something called TestRPC, which is a blockchain simulator. It will greatly help your productivity as a smart contract developer. I personally like Sublime with the optional Solidity linting that you can install. That colorizes Solidity code. It helps the brain. I also like something called Terminator, which is a terminal emulator that works well in situations where you have lots of consoles open and you want to keep an eye on everything at the same time. We'll be using something called Truffle, which is a framework for working with Ethereum smart contracts. It creates a wrapper and a higher level of abstraction that helps address the tedious syntax I alluded to earlier. Of course, at the beginning, this is another layer of complexity, and it's just a bit of a challenge to understand how all the parts work together, but in the long run, Truffle is well worth it. And we're going to start by introducing Mist, which is Ethereum's own Web3 browser. It has an Ethereum wallet. It lets you talk directly to smart contracts, and it's also a web browser. So that means that it's a web browser that understands Ethereum. Mist is a perfect introduction to Ethereum itself.